Good morning, good afternoon, good evening, depending on whichever part of the world you're joining from. Am I audible to you? Let me quickly go and check across platforms. If you're streaming live conveniently for anyone and everyone who's joining us. By the way, my name is Mudit and I'm from Pathway. What's Pathway? What is Programming Club at IIT Kanpur? What's COPS, IIT BHU? Uh, can you hear myself? Yeah, we're live. And what's NPCI? We'll quickly understand that. I guess if you're joining from any part of the country in India, so you would pretty much know about NPCI. They are the makers of some really cool products like UPI. They also manage BBPS, IMPS, RuPay, and whatnot. Like think of a fintech product in India. That's how I remember them, and it's led by someone like NPCI. And today we have their AI leader. We have Jay, who's the head of data science and AI initiatives at NPCI. But before that, let me quickly loop in my my colleague from Pathway and counterparts from IIT Kanpur and BHU. I think BHU folks are struggling to join live, but we have Claire, who's a co-founder and chief operating officer of Pathway, and Divyansh from Programming Club at IIT Kanpur. So welcome to this particular session. So Claire, would you like quickly introduce what Pathway is for those of us who do not know what the company is or what it does as for developers?
Yeah, sure. So welcome everyone. Thanks a lot for joining. So Pathway is the world's fastest data processing framework that handles batch and streaming data in a way that is easily accessible to both Python and AI developers. It's made available for download as a Python native package on GitHub, so you can take a look at it. And specifically for RAG, Pathway enables to have a RAG backend set up in a few minutes with high accuracy, live synchronizations of data sources, and unstructured document support. So hope you learn a lot, and don't hesitate to reach out if you have any questions.
Hello everyone.
Thanks.
Hello everyone. I'm Divyansh. I'm from the Programming Club at IIT Kanpur, and we're a group of students. We're a group of students here at IIT Kanpur who are really interested in programming, and we cater to a lot of stuff on campus. We have a lot of products that we build for the campus, and a lot of we conduct a lot of sessions, etc., for people on campus so that they can learn. And this is one of our initiatives in collaboration with Pathway and Cops. And hope you guys enjoy.
Thanks for the introduction. And what's IIT Kanpur? If you can do a quick introduction, I think most folks in India would know what it is. But if there's someone joining from some other part of the world who do not know what this is, so it will be helpful.
Yeah, so IIT Kanpur is one of the premier engineering institutions in India. So we have 23 IITs, which is the Indian Institute of Technologies, and IIT Kanpur is one of them.
Okay, thanks. The 23 number is a learning for me as well. And as a part of the co-organizer for this particular session, we also have folks from IIT BHU who are not on this particular stream, but they have pretty much been an equal contributor in making this happen. We have the Science and Technology Council at IIT BHU Varanasi and the Club of Programmers, as they call themselves as COPS at IIT BHU. They're responsible for building the programming culture at the campus and beyond. So that's a quick intro of everyone. Now I'll quickly introduce Jay as well. So Jayprasad is basically the head of data science and AI initiatives at NPCI. He is a graduate of Haas School of Business from UC Berkeley. He has led AI initiatives at the company for a long period of time, and he's also a graduate of University of Mumbai. In this particular session, he'll be taking us through the journey of RAG, end-to-end journey, starting all the way from hardware considerations to upwards to something like the real RAG application that is serving users at scale. So without any further ado, let me bring Jay on the screen. Yeah. Hey Jay, hi.
Hi everyone. Welcome. Let me start with the slides.
Sure.
So Mudit, I think I can start, right? So
Sure.
sure. So welcome to this session, everyone. This is a topic which I've titled as building an end-to-end RAG. RAG seems to be the flavor of the month and flavor for the last few months. So it seemed appropriate that we should possibly do a session here. My name is Jayprasad Hegde. You can call me as Jay. I head the data science and new AI initiatives at NPCI. A quick word about NPCI. NPCI is all about the digital payments infrastructure in India. And you would have heard of at least one of these words here if you're an Indian, right? Because we maintain and we architect a lot of these digital payment systems. So UPI, which is the uh, primary digital payment system in India right now, doing almost 80% of the digital payments, as was reported a few weeks back, I suppose. Uh, IMPS, which has been the age-old enterprise grade digital payment system. CTS is where you do your check clearance, still works and still works at that scale. NACH is where a payment system which allows for EMIs to happen, your loan payments, your home loans, etc. For instance, go through NACH. But the other way is also true. The government ends up giving direct benefit transfers to the citizens through NACH. Things that you would possibly take for granted, like taking your ATM card to any ATM in the country, is achieved through things like the NFS system. And if you go to much more uh, rural places, you will see Aadhaar enabled payment systems also in play, right? And then you have the things like RuPay credit debit cards and national common mobility cards, which have come into fore the last few years and uh, are presenting India's own way of doing credit and debit card. And finally, you have the two systems, which is NBBL, where if you have like a Google Pay or a Phone Pay or Paytm, what have you, and you want to do an electricity pay an electricity bill, for instance, or an LIC premium, you can do it through this system. And the most recent uh, product of our journey has been the digital rupee, right? These CBDC. Now, it might be evident by now that these are all India scale projects, billion people scale projects, right? But they're all operated on a homegrown AI platform built on open source right from the ground up. So we have large data engineering systems. We have we have needs for high speed and volume inferencing. We have large training workloads. We have large analytics. We ask very large questions of the database, for instance. And if you have several data scientists who are working in the team, you'll need a notebook ecosystem to serve their interests. So we have a notebook ecosystem, and we need to do fast prototyping at largest scale. So even our prototyping skills are like off the charts. And all this is served on an in-house large infrastructure. So by now, I think it would be clear the principle and the philosophy that NPCI lives with is build everything, including the cluster and the stack, and thereof. A quick word about me: I come from a multi-generational, multi-generation AI background, I think would be the right way to put it. So I started my career in an AI lab with things like genetic algorithms, uh, machine translation, information extraction, building parsers by hand, uh, building libraries by hand, right? We did not have that GitHubs or the Hugging Faces to go to. We had to create almost everything ourselves, right? From pure engineering setups, pure libraries, right up to the NL tasks or the machine learning tasks, or machine learning libraries. Then slowly graduated to machine learning approaches, to machine translation, things like information retrieval, utilizing information theoretic approaches more. And more recently, I'm into multiple AI initiatives, right from revamping the entire AI platform that we have right now on contemporary open source technology, doing traditional machine learning tasks, deep learning and graph AI tasks, and even things like generative AI. And uh, that's where we are. So, now, quick audience knowledge assumptions. You know what is an LLM, right? you know how to prompt an LLM, and if you don't know, I think you should just go to Bing and search for something, and that solves point number 2 for you right now. You have heard the names OpenAI, ChatGPT, Gemini, etc. Right? You must have heard rumors about LLMs being revolutionary. Even if that is true, I think you're a fit here. You've heard of vectors. Someone has explained the word embeddings to you. And although you might, I'm assuming that this is the case, this is still a beginner level RAG, meaning we're not going into like more than a frozen RAG presentation here. So modern day expectations of an LLM, right? Are we treating it as an oracle? Meaning, do we expect it to answer everything? I think the answer might be no, right? And maybe that's based off our recent education on LLMs. And when LLM started, I think it was quite a crazy year. Especially 2023 was a crazy year, especially with the Chat GPT revolution stepping in. But now slowly we have graduated, and we're awake to the fact that maybe it can't solve everything, maybe it can't answer everything, and maybe there is a need of assistance there. Just a quick rundown of some of the LLMs which are out there, some of the foundation models that have blossomed in the last few months. GPT-4 is always there, right? Everything is being measured against GPT-4. We are better than GPT-4 by X. We are better than GPT-4 by Y. But GPT-4 is still there. OpenAI likes to work in secrecy, and they are developing. They keep on developing GPT-4, but they're working on their own newer models in the background. Gemini is the challenger from Google. Llama 2 is the challenger from Meta, which is open weights, I suppose. Command R from Cohere more recently, and Mixtral, right? These are like legitimate challenges right now that you would see on the market. We'll revisit this again. But to answer the questions, all these foundation models have been trained on internet scale data, right? But is that data of your interest? So let's take an example. So I've just grabbed an example here of Wikipedia, which is a GPT-3 training set. So you have GPT-3 being trained on Common Crawl, which is your crawling data set. It's 400 billion tokens, amazing number. Right? Web text, another 19 billion. Right? Books, 12 billion, 55 billion tokens. And finally, Wikipedia, which allows this to be an internet scale in the first place, right? You get knowledge at that scale. Now, it may be able to answer most of your general purpose questions, and it may be able to answer most of your questions. But in the event that it's not able to answer those questions, it will be fairly imaginative about it, right? And might have trouble answering a few questions here and there, but it'll still attempt its very best. Now, this is all parametric learning, right? I gave an example in one of the slides, which is Llama 2, which appears in several t-shirt sizes, 7 billion parameters, 13 billion parameters, 70 billion parameters, and what have you. So the knowledge is stored in these parameters. The larger the architecture, the more information that it can store. This is the scaling architecture that we know of, right? And that to have a large foundation model being created, you have monster data centers being created right now. Now, but this is all reminiscent of a closed book exam. Right? The LLMs behave as if they're giving a closed book exam. They know everything, they've learned everything, and they can answer only from the things that they already know. So, which means that if you throw in an unknown or an unseen question to them, they'll behave like you or me, right? They'll try their very best to answer that question to the best of their abilities, and they might try to fool you a bit. So, which means that either we need the LLM to take a look at that new information by retraining itself, fine tuning itself, or maybe something like a RAG that we'll see shortly. Now, retraining and fine tuning are not cheap solutions, and there are several grades of expensive. Fine tuning for the start and right up to retraining at the very extreme, right? So we have a roadblock already. You need authentic and precise answers. Right? Now let's take a look at the second problem statement here. not all the documents uh, can be used for training. Maybe some are documents which are private to you, right? Private to your organization, local to you. You are also uh, presented with a very unique and a trust challenge, sort of, right? Would it be a good idea for you to share these documents with the likes of Gemini or OpenAI on an API call in some manner? Right? Is it safe? Is it even allowed for you, right, to do such a thing? Which means some Q&A needs to happen on private documents. I mean, you can't happen on the internet scale training that the LLM is already being trained for, or pre-trained for. Now, enter the protagonist, right? So, enter Retrieval Augmented Generation, RAG. Uh, so, you would hear this in several different ways in the academia. You would possibly hear the word frozen RAG, top K RAG. Frozen RAG because the LLM is not changing, but everything around it is changing, right? And top K RAG because you get some top K outputs, and then you figure out one that needs to be passed as context to the RAG, to the LLM, and so on. Now, the principle that it works on is very straightforward. You recognize two things, right? You recognize the fact that an LLM can answer very well. It's very lucid. It's very can produce a legitimate, legible output. Uh, and the second principle that we are going to introduce here is you can spoon feed what it needs to answer. And this all happened due to a Facebook paper like published in 2021 when they started figuring out how we can allow an existing LLM to go beyond its means and answer more things than it can originally. Now, this is the need of the hour for enterprise applications. So enterprise applications, they're not necessarily interested in general purpose QA. You might find it fascinating in the overall AI conversation that is happening right now, that people are worried about general purpose QA and they're worried about reasoning, they're worried about like chain of thought and all these things. But enterprise applications are very streamlined. They want to answer questions or they want to provide applications that has a certain value, right? For instance, a customer support QA chat. There are many customer support individuals. Some of them need help possibly, right? So you would possibly want them to be assisted with a customer support QA chat. You would want to see maybe relevant document snippets. Maybe you want custom domain documentation to be answered upon. Maybe for you IIT folks, you're looking at so many textbooks, you would want some answers from there, right? And answers only from there, not necessarily from the LLM. So maybe you need a chatbot for your text. Now, I'll maintain a distinction between chatbots, assistants, and agents. Although not going to use any of these words after this particular slide, it's important to make a distinction. An assistant is more than a chatbot, so it has some autonomy. It can do some calculation. It can do some external search, some action, right? And an agent is a step beyond that. So it's more than an assistant. It has planning skills, which means it can create subtasks of the action that has been given to it. It can figure out how to achieve those subtasks in a certain order. It has execution skills. It has decision making skills. And it does more than generation. And you'll see agents and that word being used more frequently in the months to come. But these are not new terminology. This is not new terminology. This terminology used to exist like 20 years back. It's resurfaced due to the revolution that we see in LLMs. So intelligent agents is a concept that has been around for quite some time. Now, the way we are going to go about RAG, as I said, you are going to provide some spoon feeding to the question that you already have so that the LLM can answer better, right? So if you look at the question and answer at the very bottom of this particular slide, that's your fundamental unit of interacting with an LLM. But what we are going to do is provide two more aspects to on the top, right? You'll provide an instruction about the general tonality of the question and answer session, and you're going to provide a context for where the answer should come from. This birthing of the context, or this retrieval of the context, is where RAG uh, shines here. So you're going to use your documents to provide the context, and you're going to give uh, the query, the original query. And I'm going to give you a global view of how it's going to look like. So you have the question, just look at the two purple boxes, right, in question. You have the query. Eventually, you'll come back with a context. The query and the context needs to be combined in a larger query form, a query template, and then provide the LLM, right, to give you answers from the document or the passage of your choice. And of course, you'll go about doing that by there is a backend process to it, which is the documents and the web pages which serve your domain knowledge will be converted into embeddings. They'll go into a matching process with the query embeddings and so on, and you'll figure out the best matches, the best passages that match the query. You'll basically filter out those patches, get those passages, figure out the top k among them, figure out the best among them, and then pass the chosen passage to the context. But more on that later. Before we start, let's behave like a good cook, right? Meaning, do you have the necessary pots and pans, and do you have the necessary ingredients here to start off with, right? Pots and pans for us data scientists is like hardware, right? Do you have the necessary hardware? I mean, and how do you assess whether you have the necessary hardware at all? And you would find this particular Hugging Face link very useful. Can you run it? Right? It's an LLM version, uh, which gives you advice on the kind of model that needs to be utilized. Maybe you have your own favorite. Maybe Llama 2 is your favorite. Right? So here I'm showing an H100 card because that's something that I deal with on a regular basis. We have uh, an H100 cluster locally within NPCI, which allows us to train large workloads. Right? And one H100 is at least 2x of a 4090. So if you have a 4090 sitting at home on a desktop machine, that is roughly 7,000 CUDA cores, and H100 has 16,000 CUDA cores. A 4090 is meant for graphics operations, shader optimizations, shaders, and stuff which have more relevance to play in the world of graphics and games, for instance. And they also do tensors, but H100 is primarily tuned for tensor calculations and tensor math. H100 has like 80 GB, whereas your 4090 would possibly come to like 24 GB. But that's all being taken into consideration as a part of this particular website that I'm referring to. Right? This it'll give you an idea about whether this card is, or how many of those cards are required for training, inferencing and training. Right? So you'll see here one H100 is good for inferencing, whereas if you want to do like training, you might require two here, for instance. Right? Secondly, we'll do the second part of the check, right? Like, which is, do you have the necessary ingredients? So we are going doing retrieval augmented generation, right? So retrieval, do you have the necessary documents already with you? If not, do you need to download them, get it near this particular unit there, which is going to run the compute for you? Excuse me. You need to find passages which are relevant from these documents, right? And finally, have you already chosen the LLM which is going to recite these as a part of its answering system? So now just a quick look at the storage and retrieval building blocks, right? So you have documents, and these documents need to be converted into passages or chunks of interest, right? Here, chunks for me, I've taken 10 sentences as a chunks, but you need to figure out you can do your own calculation about what constitutes a good chunk for you, constitutes a good passage for you. chunks need to be converted into something called as tokens. And this is a word that you'll keep hearing again and again and again. Right? If you look at the OpenAI terminology, roughly you'll see 4 characters equal to 1 token. And there's a question that needs to be asked, right? Why do you need to convert a plain text like the one that you see on the top right here into tokens like that you see on the bottom right here? These are all numbers, right? The primary reason why is this is the base language of the model. The model, the LLM can only understand tokens. It does not understand text. It does not understand anything else. The tokens is constitutes its vocabulary. So the text needs to be converted before going to the model or before going to an embedding model. Whether it's an LLM model or an embedding model, both are going to deal with tokens. So in this particular case, for instance, the text at the top has 153 characters, but it converts into 33 tokens here. So coming back again, right? I mean, given this understanding, we are going to convert your documents into chunks. Those chunks will get converted into vectors called as embeddings. And correspondingly, on the other side, if your chunks are looking like vectors on this side, on the left-hand side, your queries need to look like vectors too, to match against those vectors that your chunks are already in. The queries go through the same embedding process and they go through a matching process with those chunks to figure out the matching ones for you. Again, let's do a quick ingredients check again, right? So what about the token count? So LLMs don't deal with infinite tokens. I think Gemini had an announcement very recently that they're saying they'll deal with infinite tokens, but that's a story for after. And embeddings don't deal with infinite tokens either. So it's a standard practice not to keep your context too large because you'll face a valley problem, and there is a favoritism when it comes to picking up the right text from a given context. So you have to figure out how to keep the context size nice and crisp and small enough so that your answers can come through. So let's consider this particular embedding model, right? All MPNet based V2. This is a general purpose embedding. It's a very good embedding suggested very strongly by sbird.net. Let's look at its specs. Its max tokens is 384, right? And dimensions is 768. So also pricing matters, right? Sizing matters. So let's say we're looking at GPT-4, right? It can deal with 32K tokens. So you're talking about 384K tokens, 384 tokens only for embedding, and up to 32K tokens for creating a context. And if you look at something like a Llama 2, 7 billion parameter model, it can go up to 12K for a token. And that starts hitting like 64 GB of RAM for you. Right? On the pricing side of things, you start seeing things like Claude 3, for instance, which has a pricing of 3 million per million tokens, $3 per million tokens, right? Which means that you have to be very careful. I think you might think that this is a small number. $3 for a million is a good enough price, right? But you'll figure out that during a day, if you are hitting it with like 32K tokens, 32K context tokens again and again, it'll get exhausted very soon in the matter of under a day. Right? So understand the cost aspects here, understand the system sizing aspects here. Right? So again, once you understand what's needed for a token to be executed here, what's needed for the hardware to be run here, for instance, then you can basically go ahead with your process, right? But how do you figure out the right embedding here also? That matters, right? So a quick primer on embedding. I think you might have gone through in your course anyway, but embeddings for a word roughly describe the context of the word. Right? So a professor teaches this class versus a teacher teaches this class, you would find the professor and the word teacher uh, being used in the exact same context in these two sentences, and hence they are possibly related in some way, right? That's the general idea behind what uh, the basis of an embedding. And to form a sentence embedding, you would possibly want to do a word embedding of all the words in that sentence, and maybe do something like a mean pool, find a mean of all those embeddings. But a better way, instead of like doing these explorations all by yourself, which is a must anyway, you should try it anyway once in a while. Could a better way could be to go to something like a Hugging Face MTEB, which is massive text embedding benchmark. Figure out the top 10 and figure out what is to your liking, and you'll see a t-shirt size of the model, its expected system requirements, the kind of size that it takes on your system, and whether it makes sense for you. I would also recommend something like an sbird.net. It will give you a good ready to use sentence embedding transformer for which serves your purpose. So in this case, we are using the example that we've already seen a couple of times. And these are sentence embeddings for Python. Right? So we're going from pages to sentences to chunks to embedding. Now, again, just looking at one of those embeddings, you have the all MPNet base V2. Look at the description. It's an all-round model tuned for many use cases, trained on large and diverse data sets of over 1 billion training pairs. And you would see how to go about scoring these. A dot product makes a lot of sense. For instance, cosine similarity makes a lot of sense to be used along with this. Euclidean distance makes a lot of sense. So there is a description like that. And of course, the important parameter that we talked about earlier, which is what is the maximum sequence length. It can take 384 tokens and has a dimension of 768. So this is like your Pokédex card for an embedding, right? So the one thing to remember, embeddings are large. Then you'll see a lot of dimensions in an embedding, so it'll take more time to compute. So if you take the sentence which is described above, you'll see an embedding come with 768 numbers like this. These are 768 float 32 numbers. So you can easily understand that a given sentence, even if it might take like 10 words or 20 words or what have you, it might come back with a 768 dimension vector. And computing and going ahead with calculations with that kind of embedding is not going to be straightforward. And all the well, let's keep one small thing at the back of your mind. Try to use the hardware which is at your disposal. So something as small as this, right? Device equals to CUDA goes missing when you end up doing the coding, and that might be disastrous if the scale of what you're working with is quite high. So ensure that you're using the hardware in your code. So documents and queries are both embeddings that we've seen it over a couple of slides. Documents are converted into chunks. Chunks are embeddings. Queries are converted to the same version of embeddings. Right? Now, for matching, the queries are compared against every chunk. So this is similarity search, semantic search. So it's in vector to vector comparison, right? So if you're comparing two vectors, basically you're trying to figure out what is the angle between the two vectors. You can use things like cosine similarity or dot product, right? Which are related. So lower the angle, the higher the cosine value, right? So your cosine similarity value goes up. So you're treating every embedding as a vector in the 768 dimension space, and you are doing this cosine similarity across all of it. Now we can go about it several ways, and it depends on the kind of volume that you're working with, right? So let's say the chunks in questions or the number of documents that you're dealing with are not too many, in which case, for instance, you can compare the query against all the chunks. It's an in-memory exercise. You have numpy arrays converted into torch tensors. You do a dot product on all these torch tensors, and you choose a top k. Great up to a few million, right? Meaning you can continue doing this on your even on your 4090s if you want to, for instance. And just as a curiosity, I would want you to sort of exercise this small example, right? Try a dot product one by one on the CPU, measure it. Try the dot product again on a GPU and you measure it one by one. And then you go for a batch mode of a dot product on a GPU. You'll start seeing an order of difference or two orders of difference as you go through this entire exercise. And that's the reason one of the slides was try and remember that you're using the hardware. Right? So here, for instance, in one of these examples that I was going through, you can see it jumping from X to 7X to 50X or easily almost. Now, beyond a few million, you tried like queries being matched against every possible chunk, and you're figuring out the top 5 chunks or top 10 chunks or top 25 chunks which matter, for instance. And then you're figuring out the best chunk among those and going ahead. But what if you have more than a few million chunks here, right? You'll start hitting a performance or a size bottleneck here very soon, right? So for instance, Facebook also went through the same journey, and they came up with something called as FAISS, FAISS. It's meant to be a billion scale similarity search, and it allows all your chunk embeddings to be indexed so that a comparison can be done on a reasonable basis, not an exhaustive basis. So previously we were doing 1:n comparison. Here we could do 1:m comparison, which is much lesser than the n that we are talking about. But that m matters in the comparison. Here we'll do something called as approximate nearest neighbor search. So we are figuring out the right chunks to be matched against, but not necessarily all chunks to be matched against. And for even document sizes and volume of documents beyond those few, I think you can start looking at something like vector databases. But you can start looking at the likes of maybe Chroma, PG Vector, and I've listed quite a few, VB8, and so on, which are the order of the day right now, meaning people want to use these vector databases for a large scale operation. Right? I hope I'm doing well on time. But what I suspect is going ahead, you'll see a lot of these database providers surface from this noise. If you start scanning through the list, you'll see 25% of this list is already your traditional database providers. So people like Postgres, people like Elasticsearch, MongoDB, Cassandra, for instance, are already emerging as one of the candidates as a part of this mix, right? And you'll see more of those happen so on. But tread caution here. It's more often than not, and even in the diagrams that I was using, I was mentioning like a vector database, but it's not necessary, and it should not be your go-to right from the word go. Start working with local exhaustive searches, then work with FAISS, and then come to this vector database. So figure out what works for you. Just working with a vector database on a day one does not make too much sense. And also figure out how you can do all these things using traditional Python, right? The LangChain and Llama Index are the way to go. Apparently nowadays we make things very easy, but it's good to have a feel of the entire process of right up to embedding, right up to tokenization, right up to using the LLM and figuring out the outputs, right up to feeding it the necessary context, etc., and seeing how things come out. Right. One final thing. So start small, start in memory, data frames, numpy arrays, to exhaustive searches, and move to your larger FAISS and VectorDB kind of things. But this is not all, right? I mean, there's one step that we left out, which is once you get your top K, and if you look at the right hand part of this particular diagram, you have a box called re-rank. So you're getting K chunks of interest. Now, those K are not necessarily in the right order, especially if you start using approximate nearest neighbor or HNSW kind of methods to get the relevant chunks. You may not find them in the right order, in which case you'll have to utilize a model to re-rank them and figure out the top one, which will go as a context here for you, right? So a re-ranking method will be introduced, right? But that depends on the size here. You might go in for a small scale version as well, but I leave it to your experimentation. Basically, you have to be thorough in your experimentation all across the board. Like the kind of model sizes, the kind of embeddings that you're using, the kind of re-ranking methods that get chosen, the kind of exhaustive searches or similarity searches that you end up doing, for instance, are all up for grabs. But start small, start locally, and then build upwards. Right? I think this is the final slide. A quick message here. Horses for courses, RAG locally has a lot of benefits. I mean, you can deal with privacy issues very easily. It's completely in your control, right? Because you're not dependent on the LLM to serve your answers. You are bringing that LLM closer to your documents as opposed to like sending your documents in a context on an API. You have to understand the embeddings. The embeddings serve as a principal foundation brick here for building this entire journey. You have to understand the scale and understand what suits when as a part of your scaling journey, and understand the cost also that comes for this. Right? I'll end it here, but hope you found this useful. I'll take any questions if there are any.
Thanks a lot, Jayprasad, for the session. I think that's a lot of information condensed in a very succinct manner. So no surprises there. I did see your session at the IIM event. So yeah, it pretty much lived up to the expectations. I have a few questions that we can possibly pick. The first one is a
Sure.
very common question from Aryan, asked via IIT Kanpur's channel. The current benchmarks do not capture many of the real world performance. They sometimes are a bit biased and all. So most of the models also claim to be better than GPT-4, but they do not perform to that level. So how do you see that? And then he has taken certain examples like Mistral, Opus, etc. Yeah.
So, is it a question of benchmarks or LLMs? I think you take everything with a pinch of salt, which is, see, the benchmarks might not be for you. Those benchmarks are on a data set that has been created by an eval team. Right? When you're working on a very limited task, which is very local to you, you'll have to create your own benchmarks here, right? And you'll have to run it against those benchmarks. Right? But what you're talking about is more of an LM level performance as opposed to a task level performance. If you're looking at RAG, for instance, your retrieval precision goes through the roof compared to a standard LLM query that is. I mean, no comparison there, in fact. But I would say apples and oranges comparison here. The benchmarks serve a purpose, but they're meant for much more foundation LLM versus foundation LLM, right? That kind of a story. If you want to utilize, meaning that can help you figure out maybe there is an LLM of your choice. Maybe you want to use Cohere's Commandar, for instance, or Llama 2. But that now is turning out to be a question of taste more than anything else, right? People are figuring out that part of the journey. Or it's a question of whether you don't want to send your query over an API or want to use an open source model and install it locally. It's all, like I said, what do you have on your table, right? On your cooking table to utilize those things. If you don't have the necessary pots and pans, then it's just a futile reading of those benchmarks. But if, let's say, for since you have a large cluster at dispose, large cluster at your disposal, maybe you're looking at some of those larger models that can be utilized locally. But otherwise, you're dealing with just an API to API comparison otherwise, right? But that's a different journey. It's a general purpose foundation LLM versus foundation LLM created by an eval team. That won't have any bearings when you're using a very local task. That benchmark has to be created by you.
Okay, thanks. And also, you talked about information retrieval here. Nowadays, we also have these people retrievers that are there out there with Llama Index, with LangChain. Pathway also has a shameless plug, a retriever of its own. So, so how do you go about like picking something like a retriever? You build it generally in-house and see its performance, or like, or you have an iterative process.
I
Yeah.
think there's no easy answer there, right? It's an iterative process, meaning it's a discovery process, or maybe if the word of mouth is strong enough, maybe they will start using your agentic retrieval method, right? But I would generally err in favor of an iterative approach, because that way you have a tight fit. You know exactly what you're solving for, and that serves the purpose for you. It's very easy to get charmed by technology, especially in the world of LLMs, but I would suggest caution and figure out what suits you best at that point of time.
Okay, thanks. There's one question, an interesting. It's from Ayush. It says LinkedIn user on the stream, but it's Ayush Chaudhary asking this question. Can you talk about the evaluation aspects of RAG apps?
I think this is very similar to retrieval aspects. If you are used to retrieval theory, you are talking about precision, you are talking about recall, right? Here, you are going to use precision and recall. But the way to get started with the precision and recall journey for you is to figure out what a golden data set looks like for you. Meaning, how do you measure it against the golden data set? Meaning, let's say you created like some K documents have been chosen according to distribution for your evaluation, and you are going to just check against those K about how your overall RAG journey, LLM plus the RAG combination flows through, right? I think that's a good start, and that's your standard information retrieval uh, measuring technique.
Okay, thanks.
Hmm.
This is a very specific India-specific question. Um, Many foundational LLMs they underperform for Indic languages. So how do you address that, especially while building RAG apps for a place like India?
Oh my god, that's a googly, right? This is how so, okay, somebody is bowling a googly and expecting the batsman to perform well. So I'm going to use it like IPL terminology here. But me, essentially, if you're using like cricket terminology, the batsman needs to see how these things are expected to be, because your foundation models have to be strong enough to perform against that. But you're assuming that the foundation model is going to take most of the burden in answering these questions, right? That's the assumption that I see in the question here. RAG is
Hmm.
not essentially that, right? RAG is saying you have your capabilities, but I'm going to give you additional capabilities, uh, additional extensions or additional strap-ons to your Iron Man suit for you to address these, right? Uh, but it's a question that needs to be understood, how we can answer that going forward. I don't have the complete answer here about how an Indic RAG would perform well here. I have not seen too many Indic RAG systems so far, but worth experimenting it. But see, you don't need to address it specially. It's basically saying foundation LLM plus RAG, and RAG is going to basically take most of the heavy lifting here.
Okay. Also, a quick question that we saw quite frequently within the bootcamp is that with the context window of these foundational LLMs increasing significantly, do you see RAG becoming more and more less relevant with time, or is it pretty much important?
No, I think it'll become relevant, but see, I think the question is less for us. The RAG will be relevant, and RAG should be like the first go-to. But see, we are not looking at the questions in isolation, right? All the people who created and designed your foundation models are also looking at the same thing. Meta designed RAG, right?
Hmm.
Meta invented RAG. So they're also aware that people are coming up. People will gravitate towards RAG as a first go-to, as a solution which can serve their own local needs on and basically answer on their own local documents. But they would
Hmm.
want their own LLM to be all encompassing, all powerful, to basically allow this to happen in one go. So you will see some evolution on that side as well. So we ignored one part of the story, which is LLM retraining, LLM fine tuning is hard, right? And that's costly. But you'll see developments along those also take place. And RAG by itself, we just covered frozen RAG, by the way. And there are several layers to that story that I have not even touched upon. Meaning, there's several retrieval stories here that can be done. There are macro, micro retrieval that you can do, small, large context that can be withdrawn, metadata that can be withdrawn to answer your stuff better. So you'll see RAG being utilized, but understand the craftsmen in this journey, right? The craftspeople, the people who know the craft well. Uh, People are just going ahead with frozen RAG as the de facto way to utilize RAG, but that's not all. I mean, if you look at RAG and its family of systems, there are many more. I think I can do another hour after this if you want to, but those
Absolutely.
are like a family of systems which can be utilized on the RAG side of things. Meaning,
There is a question on those lines, covering,
oh my
touching
god,
up. Yeah, yeah. But we can quickly skip that or take it in with a lot of
what's
brevity.
the
Like,
question?
so we
Hmm.
covered incremental indexing with Pathway briefly in our bootcamp. With someone like NPCI, though, the frequency at which new diverse data would come in could be massive. So how do you address that?
No, I think you have to understand the task at hand, right? I mean, if you're dealing with an ever-changing data set, uh, you are going to either break your system or evolve into a new system, right? Uh, you have to figure out what is the frequency, what is the cadence at which you are updating all this. If you're doing this on an ever-growing basis, which is not always the case, I mean, RAG systems are not used for that, right? Ever-growing cases are very different in nature. Uh, and they need to be treated specially. But RAG, you would see a fairly static or fairly linear or log level growth, for instance. Uh, I think you would use RAG for those. Incrementally growing stuff, I wonder the utility of RAG in the first place in over there. I mean, what is the kind of information that you're searching? Maybe a database is best for you in that case, right? Why use RAG at all? But you figure out the journey, meaning LLM and RAG has its own use here. Not everything suits it. Right? Ever changing needs is possibly more of a database case.
Okay, interesting perspective. Uh,
See,
Slightly
let's
different.
say he's talking at NPCI scale. At NPCI
Yeah, yeah,
scale,
correct, correct. Absolutely. Yeah,
you can't even imagine me. Try to learn. I mean, let's say, I don't know, we did like India did like 14 million transactions in like last month. And
yeah,
imagine
yeah.
the number on a per day basis. You are not going to search through that numbers using LLM and RAG. That's a
Hmm.
different high performance system, but it's meant for a certain usage.
Okay, got it. Yeah, I do remember those stats. I was actually reading this interesting book where you spoke at this session. It said NPCI processes over 2,300 transactions in a minute or so, or a second. I don't remember. That's a insanely high number.
I don't know the
And
published figure, but I think
yeah,
it'll be pretty high. Yeah.
yeah. There are a few. I mean, we'll take the last couple of questions since we are
Sure.
almost. By the way, there are a few words of appreciation from various folks saying that the session is pretty amazing. Um, Now, there's a question that is
Hmm.
hmm, that is around practical aspects of RAG. If we consider demands, especially in financial sector, of data security and privacy, even on cloud-hosted LLMs like Bedrock or AWS SageMaker, can local RAG address those basically data security and privacy issues? Considering that the embeddings for context UL needs doesn't really hold the data in original format.
I think see, I'll give you a perspective. It's a hard perspective, and we take a very hard angle on things because we don't take privacy for granted. So our solution to that is we own the entire stack, right from the data center upwards, right? Which is we don't keep it to chance at all. But of course, you as an organization have to figure out what does it mean to have a local RAG on a stage, meaning on a VPC, for instance, right? I think those are assessments that you'll have to carry out in. These are pretty deep assessments, not taken for granted actually. Meaning you have to understand all aspects of the journey of the data, as a data in motion and data at rest, both pieces of the journey. Uh, and then come up with a policy or a formula that works for you. And that's very idiosyncratic as a uh, even an advice actually, because it does not mean that that policy will work for everybody, right? Meaning if you're working in very mission critical projects, I think you'll figure out you'll end up gravitating towards not just a local solution but even a local data center kind of solution. Not even, I mean, you have to figure out what are the levels of trust and who are those trusts tokens being assigned to. I mean, are you assigning tokens, trust tokens all along the way to various people that are in the loop here and there? Or is it all being assigned only to you, right? I mean, that's the part that you have to make a decision on. But it
Okay.
comes down to like governance policy, and that's an organization specific thing. It's not a straightforward journey. I mean, there are like several deep discussions happening in this area, and you have to figure out what is the level of trust that you have, right? For a national critical infrastructure, I think we take trust and issues related to privacy very, very seriously. So that we would like to govern it on our own, for instance. But it
Okay.
might be different for people, other people.
So there's a thanks from Sunil for answering this
Hey,
question. Yeah.
cheers,
And
cheers.
uh, yeah, just a quick time check. So we have last 2-3 minutes. We'll take one last question. This is from Ayush again, from June 11. I think, yeah. So do you see a financial? This is to you as an AI leader from India. So do you see a financial
Absolutely,
foundation
absolutely,
Bloom GPT? Yeah,
absolutely.
you see that?
I
Yeah.
think,
And,
yeah,
and
yeah, good.
and where do you think it might come from? It's the young Turks from IITs or some heavily funded startups
I
in
think,
India?
yeah, India has the capability to throw several surprises, right? I mean, there is some maybe there's a energetic individual sitting in one corner listening to my talk, getting inspired, and maybe he or she does all this, for instance. Uh, I think you never know. But I would say I would want India to do a lot more foundational model related work. I think we are a little behind on that journey. But I think we need to catch up very quickly. I think there's a lot of hope and promise here. I uh, would be very proud to see that happen. Right? Any of these things, even a financial foundational model being done, or something at a very large scale. Right? It'll be very impressive and very inspirational moment for everybody here.
Okay, nice. I have a follow-up question here, but I'll skip that given the awareness of how closely your words are tracked and interpreted. So I'll skip those. But there's
Okay.
one last question that
Uh,
we'll pick, and then we'll wrap this.
yeah.
Uh, okay, this is okay. There's an interesting question, but that's slightly longer. Maybe we can park it and answer it offline. But there's one very specific question that was asked before, so we're picking this. Asked by Jeet. It's around a particular use case where you're building an application for Indic languages. So he's asking like kind of an approach that you would take here if you'd like to give an answer right away. If you think there's an obvious answer to this, so to first use an Hindi
I
OCR.
think no obvious answer here. Meaning, I think see both have their merits. If you want to first use a Hindi OCR and translate in English and do the rest of the chunking and further process, or use an Indic LLM, I think both are valid approaches. I think time will tell which one should progress, but I think we should try to do Indic LLMs as much as possible. I think we as Indians should at least head in that general direction of using Indian languages as legitimate first class objects of software. Right? So
Okay, thanks for answering that. And with that, we are wrapping the questions for today. Um, and I would also first off quickly thank all the folks who are watching us live across platforms. I see a sizable number of people on LinkedIn, so you can, by the way, find the profile of Jayprasad as speaker in the about section of the event. So you can go, you can follow him and the awesome works he does and his team does. You can also find NPCI across various socials. And Jayprasad, again, thanks a lot for being on the session, being very patient and answering a massive range of questions, tricky googlies to be taken also, but you handled them very well. So thanks for that.
Thank you, guys. Thanks, Mudit.
Thank you. Thank you. Take care. Bye.